push, right? We're doing question 6, again, of the June 2023 exam paper for matriculants in Gauteng that was written on the 9th of June, which is the date of the recording, right? So let's push. So 6.1, right? So this is calculus derivative, right? So they want us to find the derivative, right? Or in other words, f prime x, right? Using first principles, right? So let's just establish what our answer will be using the power rule, right? So here we know that f prime x, just by looking at that, is going to be equal to what? 3. And then we know the power rule, guys, right? So here we have an invisible 1 there. It's 3x to the power of invisible 1. So that 1, which is the exponent of x, multiplies with 3. So we're just going to have 3. And then we're going to have x1 minus 1. So we multiply the exponent with the coefficient and then subtract 1 from the exponent. And then we know that it's going to be minus 2x squared minus 1. So we just subtract 1 from the exponent. So we know that our answer will be 3 minus 2x, right? So this is our answer that we are anticipating, but we need to use the first principles, right? So let's go. So let's just write it down here. We have f of x is equals to 3x minus x squared, right? Let's push. So now we understand that we need f of x plus h, right, from the first principle, right? So let's go f of x plus h, right, is equals to, wherever x is, we replace with x plus h. Let's go x plus h here minus x plus h all squared, right? So let's expand. So this is just going to be 3x plus 3h minus, right? So let's not distribute the negative before we do the exponent, right? So let's go x squared plus 2xh plus h squared. Now we can distribute the negative, so we just still have 3x plus 3h here, minus x squared minus 2xh minus h squared, right? So now we have f of x plus h. So now we have f of x, we have f of x plus h. So now we can go straight to the formula and shoot, right? So just minimize this, right? Let's push. So we know that f prime of x, right, is equals to limit as h approaches 0. So this is very important, right? This limit as h approaches 0 at the mark, and then f of x plus h minus f of x over h, right? So equal to, let's replace now, limit as h approaches 0. F of x plus h, we have it there as 3x plus 3h minus x squared minus 2xh minus h squared, right? So somebody may be asking, guys, what's the significance of this limit as h approaches 0, right? This thing here, right? So if I were to break it down, right, which is out of theory context, right? But the way I see it is that really, right, we really want to make sure that h is 0. We really want to replace h with 0. But we can't in this case because we understand that if we divide by a negative, by a 0, the expression is invalid, right? So we just want to make sure that we remove that denominator so that we can safely replace h with 0, right? So this is what we mean, right? So it's limit as h approaches 0. So we really want to replace h with 0, but we are restricted because it will make our expression non-real because we can't divide anything by 0, right? So that's how I see it. Okay, let's resume, right? And then we have, okay, it was minus h squared, right? And then we know that it's minus f of x. Let's put the brackets there. Our f of x is 3x minus x squared, right? All over h. So let's just simplify that, right? So we understand, guys, that here this 3x is going to cancel out with this negative 3x. Once you multiply that, right, into, we're going to have negative 3x and then negative 3x, and 3x are going to cancel out. It's just like 1 minus 1. They cancel out. It's 0, right? And also, we can see that this negative x squared here, once you multiply this negative inside there, we're going to have positive x squared. So negative x squared, positive x squared, they cancel out, right? So we can circle those. And yeah, just to save time, let's push, right? Let's push. Is equals to limit as h approaches 0. So we still can't replace h with 0 because we still have the denominator as h there, right? So let's push. So what we have in the numerator is 3h minus 2xh minus h squared, which is what we have left there, all over h. So now, if we find a chance, right, where we can remove this denominator, right, as h, right, alone. You understand what I mean? And yeah, then we can safely replace it, because at the moment we cannot replace it with 0, which will make, because it will make the expression unreal, right? Because we can't divide anything by 0, right? So let's go, limit as h approaches 0, and then let's take out h as a common factor, right? Because we really want to cancel that h out there, right? So we're going to have 3 minus 2x minus h all over h, right? So this can safely cancel that out. So now we have limit as h approaches 0, 3 minus 2x minus h. Now we can safely replace h with 0. So therefore, it is equals to. So now we don't need to write the limit as h approaches 0, because it is applicable now. It's legal for us to replace the h with 0, because it won't make the expression unreal. So therefore, our answer is 3 minus 2x. That h is just going to be 0, so we don't even need to put it. So yeah, so this is what we have here. And let's see what we anticipated. We wanted 3 minus 2x. By using the power rule, we got it using the first principle, so we're okay. Right? Right, now let's move to 6.2, right? So determine dy over dx. So this means just derive the expression of y in terms of x, right? So that's what that means. So we need to find y alone, and then we derive it, right? And yeah, so let's go. So now they want dy of dx. So let's go. We have y is equal to x minus 3 root. Okay, let me just write that there. Y is equals to 3 x minus 3 root. Let me just make sure. 3 root of x all over x squared, right? Definitely, that's what we have there, right? So now we need to derive this, guys, right? So, but to derive this, guys, we need to just make sure that our things are straightened out, right? So before we once this derive, just make sure everything is straightened out. If it means that taking out the denominators, right? As let's say we have unknowns in the denominator, right? Let's say our x is a denominator, right? It means that if we want to put it straight out, it means that we have to take it to a power, right? That is opposite to the sign of its original one. But it's okay, we'll get there, right? So let's push. So now we have y is equals to, it's very, very legal. Once we have a plus b over c. This is the exact same thing as a over c plus b over c, right? So let's do that now. So now we have what? X over x squared, right? Minus 3 root x. But instead of writing root x, let's write x to the power of 1 over 2, right? And this is all, no, sorry about that. It's all over x squared here, right? So what we actually do, guys, we understand that the laws of exponents, right? So if I have a to the power of n over b, well, okay, no, it has to have the same base. A to the power of m, this is the exact same thing as a to the power of n minus m, right? So we subtract when we're dividing, right? It's the law of exponents, right? So let's push. Let's push. So now what we have is x to the power of 1 minus 2, right, is equal to, minus 3 x to the power of 1 over 2 minus 2, right? So now everything is straightened out. So let's just deal with that. So here we have x to the power negative 1. And let me just do this, minus 3x to the power of, so this is just the same thing as 2 over, okay, this is the same thing as 4 over 4. Right, so that's negative 3 over 2, right? And then now that everything is straightened out, remember this is y, guys. We're not going to write dy over dx because we haven't yet started deriving using the power rule, right? But now that we have everything straightened out like this, that's when we can apply the derivative. So dy over dx, right? The derivative of y in terms of x, right, is equal to, let's use the power rule, so it's negative x to the power negative 1, negative 2 minus 3 over 2 times 3. That's going to give us positive 9 over 2, I suppose. And then x. So let's just take negative 3 over 2 minus 1. That gives us negative 5 over 2. So yeah, we're done deriving, right? So we can stop here, or maybe if your teacher wants it in negative exponents, let's do that. We're going to have negative 1 over x squared, right? So now when we take it below, just make sure that the sign of this changes, right? Plus 9 over, it's going to join the 2 there, 2x to the power of what? Positive 5 over 2 now, right? So yeah, we have that. So let's move to the next one, which asks us, they say that 6.2.2 asks y over 3x is equal to 1 plus x squared, right? So it says y over 3x is equals to 1 plus x squared. So remember, guys, when you're asking for dy over dx, we need to find the derivative of y in terms of x. So we just need to find y. What's y here, right? So in order to find y, we need to remove that 3x as a denominator there, right? So now before that, let's expand on the right-hand side. So when we expand, we're going to just want to write it like this. X squared plus 2x plus 1, right? And then now we need to multiply 3x on both sides so we can remove the denominator because it's dividing. To get rid of it, we need to multiply. So we multiply both sides. So if you multiply the left-hand side by 3x, we're going to get y is equals to 3x, right? Let me just put like that. X squared plus 2x plus 1, right? So this means that this is equals to 3x cubed plus 6x squared plus 3x, like that, right? So now this is y. So now what do we want? Everything is straightened out now. So now let's find the derivative. Dy over dx is equal to 9x squared plus 12x plus 3. And then, yeah, I believe we're done with that one. So let's move to the next question. Okay, so 7-mark question, okay? So they've given, they tell us that a function h is given, right, by, okay, look at this. It says the function h is given by h of x is equal to ax squared plus b over x, right? And has a minimum value of 12. If x is equal to 2. So look at this, guys. What they tell us, can you see that we have ax squared there? So we already suspect that that's a parabola, right? So now, since it's a parabola, right, we understand the parabola can either have a minimum value or a maximum value. But in this case, they tell us specifically, right, that this specific one has a minimum value of 12, where x is equal to 2. So what, in essence, what they're telling us is this is a smiling parabola because that's the only one that has a minimum, right? And the value of the turning point, look at this, the coordinate of the turning point. So what they're telling us, let me just change the color. We've been using this one, right? So they tell us that we have that. And the coordinate at that point, right, is 2 and 12. So now that tells us two things, right? So first of all, it tells us a coordinate on the graph. That's the first thing, right? But it also tells us the value of x, right, where the derivative is equal to 0. Remember, guys, when we talk about the minimum and maximum, right, we understand that derivative is equal to 0, right? So here we understand that h of x, h prime of x, has to be equal to 0 at minimum, right? And we're going to be solving for x, but they've already given us that x value there. So it helps us, understand, right? But yeah. So I just want to quickly ponder on something, right, that I've learned recently, on how we just say that the derivative, right? Let me just go all the way down, right? Let's just say, okay, how we understand that the derivative, right, of the maximum or minimum, right, is 0, right? So we can just ponder on that just a little bit, right? So for those who do physics, right, this is what you usually see, right? You'd get that y is equals to what? Vi, change in time, plus 1 over 2 acceleration time squared, right? So this is what we have there, right? So let's find the derivative of this. Because when we were talking about derivative, we were talking about the gradient and also the rate of change. And most of the time, right, when we talk about the rate of change, rate is the same thing as time. So now let's find the derivative of this in respect to t. So now what this is dy over dt. Right, just follow, right? So now, let's go. So here we're going to have vi, right? We understand that if this is x, right, we're just going to record vi as a constant, that is, a coefficient of x. And since x is to the power 1 in this case, which is just t alone, it means that vi remains. And then we understand now that we have exponent 2 here, and we just multiplied with a coefficient of this t squared, because we're deriving in terms of t, right? So whatever is next to t is its coefficient, right? Whatever is next to t squared is its coefficient. You understand, right? Because we're deriving in terms of t, right? But okay, plus, so 1 over 2 times, or half, 1 over 2 times 2, just 1. So we're going to have plus a t, because the t, which was squared, is just going to become t because we subtract 1 from the exponent. So does this look familiar, right? So this looks like the formula Vf is equals to Vi plus a delta t, change in time, right? Which is just the same thing as t there, right? So this tells us, remember guys, this is the derivative. This is the derivative, right? But we've just written it in terms of, physics principles, right? But look at this, right? Vf is equals to Vi over t, right? So let's just say we throw an object. Let's just say we're talking about VPM. We throw an object in the sky, right? So at maximum, we understand that the final velocity is equal to 0. So in this case, in order to find the value, right, so in order to find, right, in order to find anything related to VPM, right, and they say find the speed at maximum, right, we understand that the speed at its maximum point, which is its turning point, is equal to 0. So what we'd usually do is 0 is equals to what? Vi plus a delta t. But remember, this is that. And this is the derivative. So it proves that the derivative, right, at its maximum is 0. So that's just something fun to note, right? But it's okay. Let's go back to our question, right? So so that's what we had there. So that's what they told us. So it's h of x. So I just want to write that down, h of x. So I just want to create a totally new page for that, right? So let's go. H of x is equal to what? Ax squared plus b over x. Is it plus b over x or minus b over x? Let me just make sure. Right, it's plus b over x. So now it has a minimum value, right? So let's understand something. We're going to have two equations. First of all, we're going to have an equation. Remember, guys, we have two unknowns and we have two pieces of information that we need to use in order to find both of the unknowns. You understand what I mean? So it's going to be some sort of simultaneous equation. So we're going to get there. Look at this, guys. Right? So a function h is given by wara. So it's fine. It has a minimum value of 12. So first of all, guys, this is a coordinate on its own, 2 and 12. So let's start with that. Right? Let's start with that. Right? So we know that h of 2 is equal to 12. That was given to us. Wherever 2 is on that graph, it's also 12. As much as it's the turning point, it's also a coordinate on the graph. So let's push now. So let's push. 12 is equals to wherever x is, we replace with 2. Right? So a into 2 squared plus b over 2. So this is what we have here, right? So we have 12 is equals to 4a. This is plus, I just want to write it in this way, 1 over 2b. I just want to write it like this. So now, what I usually do for simultaneous equation, I just always want to make something subject to the formula, right? So let's go. Let's take this to the other side. So we're going to have 12 minus 1 over 2b is equals to 4a, right? So I want a on its own. So I'm going to divide everything by 4. So 12 divided by 4, that gives us 3. And then 1 over 2, 0.5 divided by 4, that gives us 1 over 8. So we have minus 1 over 8b. So that's our a. Let me just call this equation 1, right? So now let's go back. So now we found the first piece of information, right? So another piece of information that we need to understand, they speak of the minimum, guys. When you're talking about minimum, maximum, we understand that our derivative at that point is equal to 0, just like we've proven, right? So now let's just ponder on this a little bit. So I know, okay, if I derive h of x, if I derive this graph of h of x, first of all, right, and equate it to 0, I'm going to have my value, I'm gonna, if I equate it to 0 and solve for x, the x value that I get is gonna be the x value of the turning point. But now they've given it to us, which is 2 there, right? So let's just derive this, and then we ponder on that. We just go further on that. Let's go. Right? So let's go. We still have, let's just change the color. Let's change the color. Right? So we have h of x, right, is equals to a x squared plus b over x. And remember, guys, before we derive, we want everything to be in a straight line. So h of x, before we even derive, is equals to what? A x squared, right, plus b to the power bx to the negative 1. Can you see that, guys? So we brought this up here. So it changes. Its exponent changes, right? So yeah, its exponent changes its sign, right? So let's push, guys. Né? So now we want the derivative. We know that h prime x, because they spoke about the minimum and maximum of this graph, we need the derivative, right? So let's go. 9x squared. So now we find a derivative using the power rule. So this is ax squared. This is not 9, right? So this is going to be what? 2ax, right? And then minus bx to the negative 2. So that's what we have there, right? But, let's go. But at x is equal to 2, right? Our h prime of x is equal to 0, because that is the x value of our turning point, right? It means our derivative is equal to 0, right? So now let's go replace. So now let's go 0 is equals to 2a. Our x is 2 in this case, right? Minus b into 2 to the power negative 2 there, right? Let's push, guys. So it's equal to, this is going to be 4a, and this is going to be minus b, so it's going to be minus 1 over 4b. Let me just make sure 2 to the power negative 2 is indeed 1 over 4, right? So it's minus 1 over 4b. So that's what we have there. So remember last time we made a subject to the formula. I want us to do that again, right? So let's take this to the other side. So we're going to have 1 over 4 b is equal to 4a, right? So let's divide both sides by 4, because I want a subject of the formula. So a is equals to 1 over 4 divided by 4. I believe it's 1 over 16b, right? So now that's what we have there. Yeah, it's 1 over 16b, I think so, right? So it's fine. So that's what we have. We have a subject of the formula. So this is our equation 2. So since we made both equation 1 and equation 2 equal to a, it means they're equal to each other. Because if I'm equal to t and you're also equal to t, let's say your name starts with t, it means our names are equal to each other. You understand what I mean? Yeah, but you get it. You understand? But it's fine. So let's push. So now that since both of them are equal to a, I'm just going to say equation 1 is equals to equation 2, right? So now let's go. Our equation 1, what did we have? We had a is equals to 3 minus 1 over 8b. Let's go. 3 minus 1 over 8b, right, is equal to 2. Equation 2, which is what? 1 over 16b, right? So now let's group the like terms. So now we're just going to have 3 alone on this side. And then it's going to be 1 over 16b plus 1 over 8b, right? And then we have 3 is equal to 3 over 16b, right? So now we just one step away to get the value of b. So we just need to divide both sides by 3 over 16. So I'm going to say 3 divided by 3 over 16. And then I get my value of b as 16. So now that my b is equal to 16, and remember we've already expressed a in terms of b, so we can just find the value of a net, so, right? So a is equal to, remember, I want to use the one at the top. Hold on. Where is it? Where is it? Yeah, we had a is equals to 3 minus 1 over 8b, right? A is equals to 3 minus 1 over 8b, right? But now I have the value of b, so a is equals to 3 minus 1 over 8, right? My value of b is 16. So a is equals to, so 3 minus 2, a is equal to 1. And it makes sense, guys. Remember, let's go back to our thing, right? Let's go back to our question, guys. So they tell us that this is wara ax squared. So we understand that for a value, for a parabola to have a minimum value, right, which means it's a smiley face, its a value must be positive, and we got positive 1, right? So if we got a negative a value, we should just check if we haven't made some mistakes in the calculations. And yeah, that's quite a long one, but yeah, this is the one. I believe we're done with question. yeah, question 6 point. Yeah, we done with question 6, and then yeah, that was it for question 6. I hope you enjoyed. Just recommend it to other friends. I'd appreciate it, and then yeah, let's just keep pushing. All the best. All the best. Sure.